The mass MP of some planet, some other planet in the solar system, is 230 times the mass. Oh, you know what? When I copied and pasted this, so this should be, let me just change this. MP and some other planet. This is like subset notation, right? All right, so we're talking about the mass. So the mass, the mass of some other planet is 230 times the mass of Earth, and its radius of the other planet, RP, lowercase p. It should be subset, but I'll when I go to do the math, is 6.2 times the radius of Earth. What is the gravitational acceleration on this planet? And I think we went over where the 9.8 comes from, right? Remember we did that? So let's just start with that. When we say the force, gravitational force, right? The formula for that is the gravitational force is the gravitational constant, capital G, times the mass of the first object times the mass of the second object, right? Divided by the radius or distance from the center of that object to the center of the other object. Okay? So we also know that if I want to, I replace this Fg, right? Force is just mass times acceleration, isn't it? So I would call this m1 times the acceleration due to gravity, which we call lowercase g. And so you kind of cut out the force, right? But if I divide this, do you guys remember how we did this? If I divide both sides by the mass of the first object, the mass is irrelevant, and the acceleration due to gravity is based on the mass of the Earth and basically the radius of the Earth, or whatever the object is. So these cancel, and then I get a new formula that the acceleration due to gravity is the gravitational constant g times the mass of whatever object you're measuring divided by the radius of that planet. Okay? So now let's list some of the things that they're telling us. They're telling us that the mass of P is equal to 230 times the mass of Earth. And then the radius of P is equal to, bless you, 6.2 times the radius of Earth. So there's two ways you could do this. You could calculate this, right? In other words, if I wanted to find the acceleration due to gravity of this planet, I would have to know the mass of this planet, and I would have to know the radius of this planet. And I could actually calculate that. Or you could do a proportion. So how do you guys want to do it? Do you want to look up the mass of the Earth, create a new number, or do you want to do the proportions? You look it up. All right, so what we'll do, let me just show you how to do this. So we're going to do the mass of the Earth. The proportion way is a lot less numbers, a lot less calculations. I'll do both. Okay, so this is the number here. It's about 5, we'll just call it 6 times 10 to the 24 kilogram. So the mass of the Earth is 6 times 10 to the 24 kilograms. So then what I would do is I have my gravitational constant, right? You guys know that off the top of your head? If you don't, you look it up. Gravitational. Oh. All right. Well, I'm going to look this up for the students that don't have it memorized. You guys can debate that later. So it's 6.67 times 10 to the negative 11, right? So I'm going to start plugging this in. So this is going to be 6.67 times 10 to the negative 11. Oh, now I broke my computer doing that. Or you got to be kidding me. I hate when this happens. Then resume, then do this, then we bring it back. Times 10 to the negative 11, that's my gravitational constant, times 230, whoops, times, we're going to say, well, maybe I should be a little more precise. What was it? 2.97. Let's just do 2.97 instead, just for fun. Bless you.
Thank you.
So we'll say 5.97 times 10 to the 24. That's the mass of Earth. I ran out of space. Okay. Divided by 6.2 times the radius of the Earth. So I need that. Mass of the Earth, density, what's the radius? Oh, well, we'll just type it. Radius of the Earth. Wait, did it ask for the proportion? Okay. So the radius of the Earth was 6.37 times 10 to wait, let me double check this. So it's 6,000 kilometers. So what's that, 10 to the 6th, right? Because the kilometer is 10 to the 3rd. And then I already did scientific notation, so it'd be 10 to the 6th, yes? Yes, Mr. Adams. 10 to the 6th. All right. So now we got to plug this in the calculator. So I'm going to just do this on the other screen so I can see two things at once. And then I'll bring it over and you'll be like, oh, okay. So on the top I've got 6.67 times 10 raised to the negative 11 times 230 times 5.97 times 10 raised to the 24. Then on the bottom I have 6.2 times 6.37. Oh, this has got to be squared, you guys. What the heck, man? That's got to be squared, but that doesn't look like a 2. This has to be squared. Oh, no. Not now. Okay, let's try this again. Boop. 2. All right. So that 6, 7 times, or no, 3, 7, haha, times 10 to the 6th power, but this whole thing has to be squared. I feel like I'm missing because I'm off by 1 unit. I'm off by 1 order of magnitude. So the mass of the Earth let me double check this. So 6.37, that's right. That's right. I feel like I'm missing something here. Let me look at the questions. Oh no, it's not. It's not off. Compared to the mass on Earth. Oh, okay. Yeah. All right. So no, I'm not off. I got this. You guys ready? So now, according to this, because it's such a larger planet, the acceleration of this planet, GP, is equal to 58.72 meters per second squared. And so when you compare that, remember that we're trying to compare the proportion part. In other words, we try to figure out what do we multiply this has to be equal to some multiple of the acceleration due to Earth, right? So we would just say GE times GP, right? Or some value X. But what is GE? It's 9.8. And remember, GE is the acceleration due to gravity on Earth, which is 9.8. So we'd say 9.8 times X. I don't know why I wrote down the 6. So then we divide this by 9.8. Divide this by 9.8. And so if I go into my calculator and I take this 58, whoops. Um, 58.72, and I divide that by 9.8. Oh, come on. I get 5.99. So I get 5.99 is equal to X. In other words, GP is equal to about 6 times G E. I think I said the wrong thing. So the gravitational acceleration on this other planet is about 6 times the gravitation acceleration, or acceleration due to gravity, on Earth. And that's your answer. Does that make sense? Now another way you could have done that, because I said I'd do both. Another way you could have done it, which is a little less work, I could say, well, what's the relationship between GP and GE, right? The two different accelerations. Well, then that would be MP. Well, technically it'd be GMP, right, divided by RP squared, all over the mass of the Earth divided by RP, or RE squared, times G. And then obviously then we know that the G's would cancel out, right? And then you could rewrite this in the next line and say you could plug those things in, right? So we know that MP is 230 times ME. And then we know that RP is 6.2 times the radius of Earth, and that whole thing would need to be squared. And then you just leave this ME divided by RE squared. And so then the ME's cancel out. And then you have to distribute this through. So the next line would be 230 divided by 6.2 squared RE squared, all over 1 divided by RE squared. So then the RE's cancel. And so then you end up with 230 divided by 6.2. And if you do that on a calculator, it's approximately 6. .98 actually is about what it would be. Does that make sense? Okay, that's it. Are there any other questions that you would like